My name's Eric Nickel. I'm the Director of Operations with the Petroleum Technology Research Centre. We're located right next door, the building with the pump jack in front. You can't miss it. We work in oil and gas, and we're very proud to have some great oil and gas and CCS experts here as well to talk to you today. Sitting immediately to my right is Jason Skahar. He is the President and CEO of Bonavista Energy Corporation in Calgary. Jason has 25 years of experience in the oil and gas industry. He joined the Bonavista team in November of 1999 as a production engineer and became the Vice President of Production in January of 2005. He became Bonavista's President and Chief Operating Officer in November 2008, and then President and CEO in December of 2012. He graduated from the University of Saskatchewan. I have to mention this because he graduated from the University of Saskatchewan, as did I, in 1994, as did I, with a Bachelor of Science with distinction in mechanical engineering. I was in geology, so it's a little different. We'd probably cross paths somewhere there, I would imagine. Next to him is Ms. Beth Hardy. She is the Vice President of Strategy and Stakeholder Relations with the CCS Knowledge Centre. And as in this position, Beth leads the Knowledge Centre's considerations of policies and regulations that foster CCS, that's carbon capture and storage for all of you, and focuses on helping to link CCS knowledge with other countries to reduce locked-in investments and collaboratively support the goals of the Paris Agreement. Wow, that's a mouthful, and I'll get Beth to expand on that a little bit later. Originally, we had Mr. Kelly Knorr of SRC. He was unable to make it here today, so ably filling in for him. Next is Mohammed Imran. He is the manager of Enhanced Oil EOR Field Development Business Unit, Mining and Energy Division at the Saskatchewan Research Council. That's a mouthful as well. They are also in the PTRC building next door here with the pump jack in front. They work in oil. He has led many projects, including innovative proofs of concept, development and optimization of medium and heavy oil EOR processes, lab scale equipment design, and physical fluid flow and wormhole modeling. He's a very smart guy, and we look forward to getting some of his insights. Finally, last but not least, my boss, Mr. Dan McLean. He is the CEO and President of the Petroleum Technology Research Centre, the PTRC next door. Dan became President of the PTRC in May of 2017. He is the former CEO and President of Tundra Oil and Gas from 2008 to 14, and previously acquired over 26 years of leadership and technical expertise with Chevron Canada. So as you can see, let's thank all of our panelists for coming out today. And what a great sort of breadth of experience. We've got a couple of oil tycoons, we've got a CCS expert, we've got a lab guru, we've got everything up here. So I'm going to start with a question to Jason. And one of the things us that work in the oil and gas industry in Saskatchewan are aware of is that three major resource plays have developed in Saskatchewan since the introduction of horizontal drilling, multi-stage fracking in the mid-2000s. Obviously Bakken Viewfield, Viking in Dodsland, and also the Shaunavon. Each of these areas are potential targets for EOR techniques such as CO2 or hydrocarbon miscible floods or polymers. What do we need to do to encourage industry to investigate or research improved recovery alternatives given the current state of the industry?
Okay, that's a great question. We were involved in the Viewfield, the Bakken development early stages, long before post-secondary or post-primary recovery was being considered. Maybe I'll answer that more so from the perspective of engagement, stakeholder engagement. It's a big theme for us today, because 10 years ago, a company like ours would have went into that and thrown a ton of funding at the research to try to explore opportunities to enhance recovery through secondary methods. But today, that profitability in our businesses just doesn't exist. So where we've had success as an organization understanding, exploring, and progressing technology is when you get all stakeholders to the table. And when I say that, I'm referring to the regulatory bodies. I'm referring to federal and provincial government bodies. I'm referring to the academic institutions. If we can't, in this case, where the prize is potentially as large as it is with these massive reservoirs, if we can't find a way to get all stakeholders to the table to discover and advance technologies like this, it just won't work because the funding is not available solely with the owner of or the operator of the resource. We need all stakeholders there.
Thanks. Dan, do you have anything to add to that?
Well, the question speaks to what we at the PTRC have been trying to do. That is to encourage oil companies to invest in research. Jason's comment is bang on in that our best efforts to encourage folks to invest in research only goes so far. You have to look at the thing from a holistic perspective. Research for the sake of research, that's something that you would like to have, but that's not the reality. The research that the industry is looking at is stuff that has a direct application with a potential prize at the end of it. And what industry wants to see is, well, not only the size of the prize, but how does it all come together from an economic perspective? So, the fiscal terms, what are they going to look like? From a regulator's perspective, how is the regulator going to view this? And then ultimately, will the science itself work? So those three parts are extremely integral. And going forward, that is the approach that we're certainly going to take. Here in the province, the government has just introduced two new pieces of legislation to provide incentives for enhanced oil recovery and for infrastructure. And these are great, but the companies that they're targeting have to have the technical capability to implement the things that they're targeting. So there is an opportunity to follow up with companies that could potentially be using this from the perspective of helping them with the science of that.
Great, thanks, Dan. Beth, you're with the CCS Knowledge Centre.
Yeah.
Could you tell us a little bit about what that is and what your mandate is?
Sure, yeah, my pleasure. So the International CCS Knowledge Centre is actually somewhat a spin-off organization of SaskPower. We're an independent organization founded by SaskPower and BHP, one of the world's largest energy companies as well. BHP gave $20 million over 5 years for us to share the lessons learned at the SaskPower Boundary Dam facility. And so, with a design capacity of 1 million tons and capturing 800,000 tons a year, there are a lot of people all over the world that want to learn from what has been done right here in Saskatchewan. And not only is that a model that we use here, it's a full chain model that people are very interested in terms of not only the capture process on a coal-fired power plant, but also for enhanced oil recovery and for Aquastore, the storage project as well. So all of that package, there are many people, including in China in particular, where 80% of their emissions come from coal, and it's 25% of global emissions are from China. And there's a lot of opportunities there to take what we have here in Saskatchewan, and SaskPower and BHP really had the foresight to be able to create this organization, to be able to try and take what we've learned here and share it internationally. And so when you talk about the Paris Agreement, some of the things we're trying to do is to leverage the marketing mechanisms underneath that agreement to try and get some of that environmental credit back in Canada for the sharing of those lessons learned in other countries. So the Knowledge Center is much more than that, but we have the engineers that help work on Boundary Dam. We're able to help other people make CCS projects. But I'll leave it there, and maybe we can talk a little bit more about
great.
it after. Yeah.
Thank you, Beth. Some very interesting work being done right in this building that maybe some of you didn't even know was going on. Mohammed, we've worked together for a long time on a lot of different projects, and I got my start at the PTRC and running what we call our Hornet program, our heavy oil research network, and where PTRC and SRC have gone with this is a lot of work in cold heavy oil production. We've done a lot of bench scale research into different types of schemes of getting more cold, heavy oil out of the ground, and some of them have gone to the field, such as in the Jive project. What do you think the next 5 years in this research looks like? Is there more bench? Is there more field? Is there a combination of the two? And where do you see cold, heavy oil production going?
Thank you. I have been with SRC for the last 10 years. I have seen quite a lot of stuff, and in the past couple of years, what I have seen, there is quite a lot of interest from the industry that really want to move the studies from the lab scale to the field scale. So the way things are moving right now, it looks like some of the concepts we are working on right now, for example, cyclic solvent injection, that is one of the key process where the major players, the operators are looking for the full field scale application. I can see maybe within the next 2 years, we will be able to, circle that whole thing and go for the full scale application. Not only this, but again, applicable to the CHOPS reservoir. Apart from PTRC, we are working on many other projects where you call it as a proof of concept. If those proof of concepts work, it looks like there is going to be a great potential in terms of, moving towards the field application. And so to answer your question, in the next 5 years, I'm a very optimistic guy, so I always hope for the best. So it looks like those years are going to be very great.
Thanks, Mohammed. Dan, maybe you could comment on, adding some context to what Mohammed is talking about in terms of the size of that prize that we're going after here.
Absolutely. Talking with the industry folks that we work with, Husky and CNRL, they think that there is a potential to recover an additional 600 to 800 million barrels of oil through cold, heavy oil production with sand or post-chops. These are wells that are currently suspended. So that's the potential size of the prize. But there's another thing out there that is weighing heavily on the industry, and that is that there are some 20,000 wells that are suspended that have the potentially need to be abandoned at some point in time. And at the current cost, about $50,000 a well, 20,000 wells, that's $1 billion in potential investment the industry is looking at having to shell out to abandon these wells. If they can extend the life of these wells further, they can manage that cost and recover more reserves to help pay for a lot of this. So there is a huge opportunity that we see. And the PTRC, SRC are working very closely with the industry players here to help them unlock those ways to sustain and improve recovery in these wells, and at the same time look at new technologies that will reduce the environmental impact of what we're doing. So there are some important things that we're doing here.
You mentioned well abandonments. This seems to be one of the looming issues in not only in Saskatchewan but in Alberta as well. A lot of abandoned wells. Jason or Dan, maybe you want to talk about what sort of are there technological advancements that can go along with maybe some sort of regulatory changes that would help that situation a bit?
Yeah, for sure. I can chime in on that briefly. I definitely can resonate with Dan's comments on all of these wells that are out there, and the push that we need to make as an industry, as a nation, to find a way to extract more out of these what appears to be liabilities today, because there's tremendous potential left in terms of the resource left in the ground. And we just need to take that step from a technological standpoint. When it comes to retiring abandonment obligations, our organization has been in business for a little over 20 years now, and we've maintained an abandonment or a reclamation capital budget in the order of $10 to $20 million for the last 5 to 7 years, and we feel as though that we've gotten pretty good at retiring these liabilities. Having said that, there's been a tremendous amount of collaboration in Alberta between industry, the regulators, the Alberta government, and last but not least, the academic institutions, to come up with a way to meaningfully reduce the cost associated with these liabilities. And it was about 4 years ago that work was put into play in the field with a number of major producers, and after a full season of reclamation work, it was discovered there was the potential to reduce costs by up to 40% if the regulator and the Alberta government would modestly change the way they're stating their regulations and asking corporations to commit to those abandonment regulations. So as of late, the Alberta regulator has made it optional, a volunteer program for companies like us to adopt what they call the ABC program, where you can move into an area and retire all of your abandonment liabilities in one fell swoop, and in doing that, delay liabilities in another part of the province that may, under the old regulations, be subject to retirement immediately in exchange for that. And that, again, has resulted in the opportunity to save a tremendous amount of money in dealing with these liabilities.
That's a good regulatory start. Are there technological or technological advancements that can help with this as well?
Yeah, well, there's a couple things I want to speak to. First of all, in Alberta, there's a company called Razor Energy, and a friend of mine, Frank Muller, is running that, and they purposely bought these old Beaver Hill Lake wells, knowing that they were there was a large abandonment liability. But what they have done is they've recognized that they can repurpose these wells. They are 99.99% water wells. They're down at 10,000 feet, and they see a geothermal opportunity. So they're actually repurposing wells that were slated for abandonment for geothermal purposes for the community that they're in, as well as help them reduce their overall energy requirements. And if you look at that company, actually, it's doing quite well. It's increasing its production. So that's the one comment. You can repurpose these wells. Second thing, I was talking to a private equity company in Alberta, and they are looking at a way to monetize this whole idea of abandonments. You've got the orphan well program. You've got the AEU who is involved in this. You know, there is a huge inventory of wells that need to be abandoned, but it's not being done very well, very efficiently. So this private equity company is going, well, can we turn this around and make it a monetary tool where people will be willing to invest in it, knowing that it's actually a declining balance kind of thing. You're actually taking that inventory, you're spending money to abandon them, but somehow through the investment process of a large private offering, you can still make money on this declining balance. So there are some interesting financial tools that people are looking at, keeping in mind that the goal is to abandon these wells, but in a more systematic way. The last thing I want to talk about from a technological standpoint is that it's one thing to say, well, we have to abandon these wells, and you try to drive your costs down and do it in the most cost-effective way. But the other part of the conversation is, can you confirm that these wells will stay abandoned? Because in addition to abandoning the wells, you have to reclaim the lands back to their original condition, plant whatever plants or whatever. But 5 years from now, who's to say that there isn't something percolating up? So I've talked to PTAC, which is the Alberta version of PTRC, and there's an opportunity for us to work together collaboratively to look at the kinds of surface monitoring technologies that could be basic to a large abandonment programs to ensure that these things are staying abandoned.
Great, thank you, Dan. Changing gears a little bit to CO2. In Saskatchewan, you've probably heard a lot about things like Boundary Dam and what's going on there, and Beth with the CCS Knowledge Centre spreading the good information about that. As someone who works in that field as well, myself, I'm getting a lot of calls all of a sudden from Europe and from the United States and from Asia and elsewhere about all these things that are going on in North America for CCS. Beth, perhaps you could tell us a little bit about things that are going on in other jurisdictions like the trunk line in Alberta or this interesting legal tool called 45Q in the United States.
Sure, yeah, definitely. So, my fellow panelists know this, but, maybe some of you would be interested to know that, with your first extraction, your primary extraction, you get about 15% of the oil. Then with water flooding, you can get about 15% more. With enhanced oil recovery using carbon dioxide, you can actually get another 15%. So that's 45%. I can't do math, but I think that's correct. I let the engineers do the math normally. But you're getting 45%. You're getting 30% more than your primary extraction. And when you do CO2 oil recovery, it's actually over 30% less greenhouse gas emissions than traditional extraction methods as well. So CO2 has a very good, what happens is it goes in with the oil and it swells it up and it creates more pressure. You know this. He can tell you way better than me. I'm doing the non-geologist way, and it creates more pressure for the oil to come out of the ground. And so it stores over 99% of that CO2 emissions as well. The CO2 doesn't come out. So all of a sudden, we're taking the CO2 from a coal plant, and that coal plant is now cleaner than natural gas. In fact, in Saskatchewan, it's cleaner than wind because wind has natural gas peaker stations for the variable load. So that base load power that comes from coal is actually now cleaner. And we're getting to store 99% of the CO2 by getting more oil out of the ground. So it's really fantastic, and a lot of people are starting to figure it out here in North America that it's a really good thing. And so in Alberta, they've just made something called the Alberta Carbon Trunk Line. And what it intends to do, it can actually hold up to 14 million tons of CO2 a year. And it wants to take CO2 from various sources and put it in various sinks. So a sink, it could be like an Aquastor site to be permanently stored, or it could be in an oil reservoir, deep down in the ground, never to come out ever again. And so it replaces where the oil was, back where it came from, people might say. So it's really great because you're creating an infrastructure hub, and now all of a sudden you're feeding into a pipeline that can go and have multiple end users as well as multiple sources. And this isn't just from coal plants. There's a lot of low-hanging fruit where there is almost pure streams of CO2, like an ethanol plant, for instance. There's ethanol plants in Saskatchewan, in southern Saskatchewan, that would probably do very well to pair into a Saskatchewan trunk line, for instance, if we were to play. And that's where people in Europe are looking to Alberta, and Saskatchewan could do the same. But in terms of 45Q, not to belabor the excitement I have for it and this whole topic, it's really great because there's a tax incentive in the United States whereby if you sequester CO2, you get $50 a ton tax credit. But if you use it for enhanced oil recovery, the company can get up to $35 a ton. So places like North Dakota, for instance, going across to Weyburn, where there's been over 35 million tons stored to date, maybe that's an opportunity for a new construction to have a 45Q. It's not being done in Saskatchewan comparatively. So these are opportunities for incentives and subsidies. You don't always have to have the regulations which cut you off on one end. You can also have the carrot on the other end that are going to incent you and take you in a different direction. So those are the types of things we discuss at the Knowledge Center as well, and I could go on and on.
Thanks, Beth. Does anyone else have anything to add to that?
Well, I always have stuff to add. You spoke about Weyburn. Since from 2000 to 2016, PTRC was the quarterback of all the research for measurement, monitoring, and verification of the CO2 EOR project at Weyburn. So we have a long history of understanding how this stuff moves in the reservoir, recovers the resource, and is stored in the reservoir. We would like to see more of these kinds of projects in Saskatchewan, and we did a study in 2006 that identified a potential range of CO2 or enhanced oil recovery from CO2 of between 0.5 to about 1 billion barrels of reserves. Now this was 2006. This was before the Bakken, the Viking, and the Shaunavon. We want to update that study And I'm envisioning that number is going to go from 1.5 to 1 to 1 to 2 billion barrels very easily. And if you think about it from the perspective of $50 US a barrel, $60 Canadian, 2 billion barrels of reserves represents $120 billion in undiscounted potential value to the province. And if the province gets 10% royalties on that, there's $12 billion right there. So there's a large potential. But so we want to identify what the size of those opportunities are. But then we'll need the help from the province to look at the fiscal terms and royalty structures and incentives that might be required. Alluding to what Jason said, we need to have all the stakeholders at the table looking at this at the same time. This will require, of course, additional CO2. Yes, we have carbon capture at Boundary Dam, but everybody knows the history of that and the politics of it, and the cost to recover that CO2 is rather high. But at the same time, there's the Shand opportunity. This is a coal-fired power generation plant right near the Boundary Dam facility, and it looks like you could put carbon capture on that for 60% of the total cost. From an engineering perspective, it would be a shame not to take advantage of what you learned in the first asset and not do the second one. But that's just an engineer talking. It'll all come down to what is the cost of delivered CO2 to the potential clients. So we're looking at all of that. I think there is a big opportunity.
Thanks, Dan. CO2 is a gas that, if uncontrolled, is seen as a pollutant, I guess, but controlled, it can be very useful. Another one that falls into that sort of frame is methane. And Mohammed, I know that the SRC is, in the expectation that there are some new rules coming down about fugitive methane emissions and so forth. I believe the SRC has positioned itself pretty well to do some investigative and research work around fugitive methane emissions. Do you care to elaborate on that?
Yes, you're right. And back in 2017, we started working on the concept of coming up with a mobile unit that can be transferred to the location itself to figure out and help the industry to find the best ways to assess the methane reduction technologies. Not only that, but also to look at what is the extent of the methane leak. Not only this, but we are also working on the other concepts like the aerial sensing of methane. It's not only the ground level, but the aerial level too. So we have UAVs and we have drones, because one of the issues with the methane is when there is a leak, sometimes it's not safe to send people there to detect the leak. And in addition to that, we have developed a database of different methane reduction technologies, over 400. So when we are facing a problem, we can go through that database and look at what is the best technology for the best application and what will be the best outcome.
Good, thank you very much. So I think...
Can I chime in on
absolutely.
that? Absolutely. Methane, obviously, a big pollutant, as everybody knows, probably 25 times more dangerous than CO2. Something that we're paying a lot of attention to, and you guys are going to get so tired of me saying the word collaboration, but I've got an example for you where, we've had some tremendous success where we as an organization collaborated with PSAC, with Baker Hughes, and with the Department of Environment and Climate Change Canada last year. We provided basically a field laboratory for Baker Hughes to test a methane sensing and analytics platform. It's a new technology that they're looking to get into the market. We had, I think, 78 sensors strapped to devices across 7 different facilities in Alberta. And these sensors monitored methane data for a period of up to 8 months last year. And in total, I think there were 190 or 200 million data points gathered in this process. But ultimately, the goal was to be able to advance industry's interpretation of methane emissions and be much more responsive and predictive on how to deal with methane emissions going forward. Because as I'm sure most of you know, a lot of the estimates that reside in a lot of the data libraries, they're exactly that. They're all estimates based on manufacturers' specifications, but there has not been a lot of real-time data measured. So ultimately, Baker Hughes is going to take this technology and showcase it across industry, and it's going to be a big part of how industry looks at sensing, measuring, and correcting methane emissions going forward. So it's pretty exciting for us.
Interesting. Yeah,
Go ahead for it.
I would like to add one thing here. You know, sensing methane is one thing, but the main thing is like, after these regulations, I guess, it will be realized to find out how much leakage is there, because with the methane, there's sources from where it is coming. It can come from compressors, from valves, from other machines which are in the field. So I think the concept, like which SRC came up with, this mobile unit to look into that, was exactly the same thing, like to find out where the leaks are, because when we know them, then we can find the ways to rectify it, right? Yeah.
And respond to them immediately.
Exactly.
Yeah, that's exactly what we learned. You know, whether it's packing on a pump or or a control valve. Yeah.
Because the sources for leakage are many. It's not single, right?
Yeah.
So
Yeah.
Well, it's a challenge and one that it seems that industry is definitely up for. It'll take some time and cost some money, but it's worthwhile in the end. You know,
The regulations are going to drive the industry's need
the
to look at this carefully, because they will come out with a set of regulations based upon that old data set. And companies will have to look at that and decide if they're in compliance or not, because if they're out of compliance, it is going to cost them.
So in sort of staying in the same realm of topics, you know, we hear a lot about green energy. And when people say green energy, we think of wind and solar and things like that, maybe geothermal, maybe, you know, tidal energy, this kind of stuff. And to me, the press has always portrayed it as something that's in conflict with the oil industry. You know, it's going to be taking our livelihoods away from us. But I think if we look at it, there are ways that green energy, such as wind, solar power, can support oil industry and help it. Jason, do you have any examples or thoughts around that kind of thing in the field?
Yeah, we've got dozens of examples where we're trying to apply renewable energy to our operations, whether it be solar power to run a methanol pump in a field or to run some controls on a field site. You know, we've got dozens of these applications. But maybe if I can stand back and just speak to, you know, speak to the perspective from a guy at an oil and gas company. You know, when I look at the projections in terms of global energy demand growth over the next 15 to 20 years, and seeing that growth in excess of 20%, approaching 30%, and when I focus in even on more specific forms of energy like natural gas, which is subject to grow between 40 and 50% by 2040, I think to myself, there's no possible way that the oil and gas sector can provide energy to meet that growth in demand without finding other sources of energy, whether it be nuclear, renewable, you name it. Inevitably, we all want to achieve a cleaner environment and a cleaner atmosphere, and we as industry and as citizens of society have to own that and be accountable for that. We have to find a way to run our lives more efficiently. We have to find a way to run our business more efficiently if we're going to meet those demand growth targets in terms of energy. So there is more than enough room for oil, for gas, for renewable energy to be able to supply the world with the energy they crave today.
Maybe, can I just touch on
Absolutely,
that as well, Eric? So, you know, I think you're exactly right. Totally right. I couldn't agree with you more. And we need more collaboration on rightness up here. This is good. But, you know, let's just take Canada. Canada is a beautiful microcosm of the world, okay? Because I have a master's in environmental law. So I went to the U of S too, by the way, for law. But, you know, Saskatchewan is unlike the rest of Canada in that, you know, there's so many hydro electricity options in Ontario and Quebec and Manitoba. You know, we get kind of painted with the brush of what's supposed to be for all of Canada living in Saskatchewan. We don't have that reliable baseload renewable power. And to some extent Alberta, but there's a lot more hydro options there. And so in order to have reliable baseload power, SaskPower works very hard to try and figure out what that breaking point is to add more and more renewables and other things onto their grid. And so when we go around the world talking about it, we find that Saskatchewan's actually similar to a lot of other places in the world, more so than it is to Canada. Canada is very lucky to have hydro as a reliable baseload source. If you look at Texas, Texas has just had a series of brownouts because, and many people will say, of an influx of renewables not being parceled with their grid stability and understanding how the grid was going to react with the influx of cheap, new, subsidized renewables. The same thing happened in Australia. The same thing happened in Australia 2 years ago when renewables were incented with the carbon tax that they had put in place, and more renewables came on board and brownouts. And so there are lessons around the world that can teach us that yes, we need renewables. We need absolutely everything. And it's not pitting one thing against the other. We need everything in order to get to 1.5 degrees Celsius and the targets that we have set for ourselves internationally to understand climate change goals. And in doing so, we need things like CCS. We're going to need to continue to have oil. We need to figure out what the sustainable balance of that is and how we can all work together and not be in competition with each other. Because the Shan report, thank you for mentioning the 67% cost reduction that we had there at the Knowledge Center. You know, we looked at it in terms of how we could work with renewables and the fluctuation on the load. And if there's a fluctuation and we have the coal plant backing it instead of those natural gas peaker stations, we can actually capture more CO2. So you can go hand in hand with renewables to capture up to 97% CO2 potentially. Now this is a high-level feasibility study, but I mean the potential is there, and it ends up going together as opposed to competing.
Well, I think this transfers pretty well into what will be my last question, but it will be to all of the panel. We're on a university campus here, and this university campus has a wonderful petroleum systems engineering program. It has petroleum geology. U of S has geophysics and programs like that. And they have students in them. And we're in an industry that some people maybe see as you know, we read about it's dying or something like that. What Jason, would you tell a new graduate in geology or geological engineering or something like that? Do they have a future in this industry?
Well, I'd start by telling them that this certainly is not the next tobacco industry. Yeah, you know what, I've been around a long time and I'm a bit of an old guy here, but you know, in my 25 or 30 years experience in the industry, I can't think of another time in that period of time where technology, innovation, creativity is as instrumental to, we'll call it the energy industry as a whole, as it is today. You know, when I got involved in this industry, it was really about business and growth and, you know, doing it the way we've always done it. Today, that doesn't work. That doesn't work. If we're going to sustain ourselves, number one, and grow the industry, number two, only way we're going to do it is if we can do the business differently today than we did it yesterday. So if that's what floats your boat is innovation and technology, the energy industry has come a long way in the last 5 years, but has a tremendously long way to go in the next decade to ensure that this industry is sustainable, but more importantly, to ensure that we as Canadians can provide energy to the rest of the world whom are craving our product.
Great. Yeah. Dan, do you have a comment of what you would tell a new graduate?
Yeah, first of all, I want to come back to something that Jason said on the previous question, and that is that his company is looking at other sources of energy to help complement and reduce their overall energy uses, whether it's solar, wind, or other areas. And so what has traditionally been referred to as an oil and gas company is really an energy company. That's what all of this sector is evolving into. We are part of that energy mix. So new graduates, I had the opportunity to talk to the engineering class last year. It was in November when Western Canada Select was in the toilet, right? It was like $17, and there was a lot of kids going, did I make a mistake? And I used that opportunity to show them, first of all, the arc of my own career over 35 years. Here's what the price of oil was when I started, and it went down to like $15 and stuck around there for 20 years before it came up to the numbers that we saw in the last 10 years. $50 a barrel US actually is a good number. And so, you know, this too will pass. It's, these are the little blips that happen with the oil price. But more importantly, I've spent 35 years of my life delivering energy to the world for the purposes of improving the quality of life of people around the world. And no one is going to make me feel bad about that. Going forward, you can look at the numbers. The demand for fossil fuels is increasing as China and India and other parts of the world look to develop a middle class. And we here in the developed world continue to enjoy the fruits of their labors at a lower cost. You know, so from that perspective, there will continue to be a need for fossil fuels, for fossil energy. And yes, it will be, the revenues from that will be used to support renewable energies. So think about a career where you can be involved in the extraction of this resource. The challenges that you face are going to be completely different than the ones that we've faced. More importantly, you have skills and resources that we never had. I can tell you right now that when I started, we didn't have laptops. You know, I did a lot of my work by hand, and then in 1984 we got our first laptop, and the world changed. Now you look at the way the skills that people have coming out of universities. We had a couple summer students, and they are absolutely brilliant with spreadsheets. Well, you know, therein lies you know, the huge opportunity for understanding data to make decisions quicker, better decisions that have the impact not only to the companies in improving oil recovery and gas recovery, but also to the environment. You have to balance those two, and it has to have an economic impact. So there is a huge opportunity going forward for new graduates.
I don't know about you, Dan, but when that young engineer comes into your office, does it make you feel a little bit old and kind of dinosaur-like?
Yeah,
it does me anyway.
So. Very much so. But you know, having summer students, I mean, that energizes you. Yeah. You see these young guys and gals, and they're just so confident.
Yeah,
I love that.
Amazing.
Mohammed, any comment on what you would say to a new graduate? You must meet some of them.
Yeah, I completely agree with Dan and Jason, but that's the overall picture. The need for fossil fuels is gonna go up. But if you look at the closer picture, after every 10 years, you will see that there is either a rise or a fall. So if we talk specifically about a process like SAGD, started from 2002, it's now downward. Why? Because of the prices does not match with that. What I believe as a researcher is that we will find a way, for sure. So I don't think that ever the future of energy or the future of the petroleum engineers here is gonna go, that there is no future. I don't see that. There is a pause for some time, maybe 2 years, 3 years, 4 years, but after that it's gonna rise for sure, because there is demand. And when there is demand, it has to be fulfilled. And I don't see any other fuel rather than fossil unless we come up with the cell phone sized nuclear devices that generate that energy that you can replace it. That is the beauty of the fossil fuel, that it gives the best calorific value in the best state. Like you will find coal with the similar calorific values, but that is solid. You cannot run a car on coal. Maybe you can, but the GHG and all this emission stuff what we are talking about, it is gonna be, nobody will let us do that, right? So for all the engineers, I think you have a very bright future. So.
And Beth, you travel all around the world. Are there a lot of gray hairs in the audience? Or are they all pretty young people?
Oh, I guess it depends where I am. Actually, in our audience right now, I've got two former graduates of the University of Regina who are now our engineers in training. They were students just 2 years ago. And now they go all over the world as well and speak to women in STEM. And we really, you know, that actually is what I would talk to. I actually have a lot of women who come up, young women who come up to me at the end of a lot of my international conferences and say to me, how do you do this? How do you get where you are? What made that happen? Well, I guess it was a lot of people telling me I was too big for my britches, mostly, but the future is there and they're really eager is the word that I would use as well. And there's a lot of things we can teach as well. That is, I think that's really important. There's a lot of people that come from all over the world to try and learn about Boundary Dam, but there's a lot of people right here that we can teach as well. And I think we often look a little bit farther than our nose and miss some of those opportunities right here.
Well, very good. I think that was a good summation of where our industry is going. So let's thank our panel right now. Great. All right, I think we'll call a close to this panel now, and the speakers will be available for conversations and enjoy some food and drink. Thank you very much.